For today, we're just going to go over our Unit 2 vocabulary. Our first word is called standardized value. That's what you get when you take a data point and scale it by the population data. So we're subtracting the mean and then dividing this difference by the standard deviation. Basically, it's another name for the z-score, as you'll see in the next slide. So standardized value is your z-score. Now what is your z-score? Like I said, it measures the distance of a value from the mean and standard deviations. So we have one specific point we're looking at. What's the difference between that value and the mean, or the average, and we're going to divide that by the standard deviation of the total of all the data points. That is our z-score. And this is what it's telling us. The distance that value is from the mean in terms of standard deviation. Basically, where does it fit in our curve? We have something called the normal model. This is the distribution whose shapes are unimodal, so we have one hump, and roughly symmetrical. So it would their data would kind of look like this. Also, you've heard the term bell curve, right? Possibly, bell-shaped curves. That is another name for a normal mode or model. Parameters. So notice with my z's value, I'm looking for the mean and the standard deviation. These values don't come from the data, they are part of the model. They're representing this right here. They are numbers that we choose to help specify the model, such numbers are called the parameters. So notice before in Unit 1, we were looking at the sample mean and the sample deviation. Now in Unit 2, we're looking at the parameters, the population mean, the population standard deviation as a whole. So you probably saw examples like out of 300 students, 20 were selected. That would be here. Here we're looking at the whole 300 students. Does that make sense? So this is the mean as a sample I've taken from the population, and this is the whole population. That's what we're going to look at in Unit 2. Everything as a whole. Standardized normal model, which that is where our mean is 0 and our standard deviation is 1. So here's our bell-shaped curve, and notice 68% of my data is exactly between a -1 and 1 standard deviation. 68%. 95% of my data is exactly between a -2 and 1 standard deviation, and 99.7% of my data is between -3 and a 3 standard deviation. Now, I ask, is this even possible to ever achieve in the real world? A perfect bell curve? No. This is just what we're going to use as a model for our data. So the standardized normal model is a perfect bell curve. It fits perfectly in these values. We're going to use that to do what's called the normality assumption. When we use the normal model, we assume that the distribution of the data is normal. There's no way to check whether this normality assumption is true. In fact, it's almost certainly not true. Like I said, let's look at, can I zoom in here? There we go. Let's look at this data here. Is it perfectly within this normal bell curve? No, you're never going to really ever get that. But can you say with the assumption that it follows a normal model? Yeah. What about this one? Would you say this follows the normal model? No, because you see it's a little bit outside our normal bell curve. So we're going to use the model to make assumptions. Again, we're never going to be exactly a perfect model like so. And then last but not least, the empirical rule, where we're looking for within 1 standard deviation and of our mean, we have 68% of our data. Within 2 standard deviations, we're going to have 99.7% of our data. And let me backtrack. Within 1 standard deviation, 68%. Within 2 deviations, 95%. And within 3 standard deviations, the majority of our data, almost all of it, is within 99.7. Why do we not include 100%? A vocab term from last unit. What could happen out here? What are these called? Outliers. We don't want to include all of it because we could have outliers that just skew our data a little bit, right? So the empirical rule, also the 60, 68, 95, 99.7 rule. I guess they got tired of saying all these numbers, so they just call it